Let's get started. Welcome to the session on rediscovering JavaScript. My name is Venkat Subramaniam. We're going to talk about some of the features in JavaScript, some of the things that we generally overlook, but I think are pretty useful and interesting on a daily basis. So we'll get started. Best time to ask questions or make comments is when you have it, so please don't wait till the end. Anytime is a great time of questions, comments, just about anything you want to talk about, don't hesitate. Raise your hands and start speaking. So let's get started. Well, I was trying to think about how to really describe JavaScript. If somebody fell off a cave, into a cave, let's say back about 20 years ago, and they just rescued this person, and the first question he asks is, what's the most popular language? You're going to say, well, JavaScript, of course, and the person is going to be in absolute denial. And I was thinking about how to describe JavaScript, and the only way I can describe JavaScript is, it's like this bad villain in a movie. They keep killing him, but he keeps coming back to life. And that's amazing how JavaScript has surfaced so many different times. Well, I'm going to talk a little bit about what's really wrong with JavaScript to begin with. Well, one of the very first problems with JavaScript is it's the inconsistencies of the language across different browsers. We keep running into errors all the time. And it's a really poor name for a language. Think about this for a minute. Would you ever do this? Would you name your child after somebody who's popular in the neighborhood? What a bad name for the language called Java. Because it was becoming popular, well, that was really a poor name. It's a misunderstood language to a great extent, and a lot of times people really fear this language, but it's actually a pretty powerful is. And there's one other problem I think we all run into. You typically go take probably a course on how to program Java or C# or F#, but how many times people actually take a course on JavaScript? We feel kind of insulted if somebody says, go take a course on JavaScript. So how does most people learn JavaScript? Well, you learn JavaScript by reading code on the web. And most of the JavaScript code on the web is pure crap. So we've been learning from really bad examples. In fact, I would say that's not true anymore. That was 10 years ago. But people have short-circuited this now, so we now simply copy and paste the bad code now. It's even worse than actually rewriting that code. So we haven't really taken the time to learn this language really well, and that's really a disservice to it. But on the other hand, JavaScript is actually quite a powerful language. In fact, it's a little too powerful for what it can actually do. And it's a dynamically typed language, but it's also weakly typed. So once you get past running the code, it's garbage in, garbage out. You better know what kind of objects you are dealing with. Otherwise, you could get into really bad errors along the way. It's extremely flexible. And in fact, very rarely do you have to really use a framework for mocking and stuff like that. It's extremely easy to add methods to classes and change methods as well at runtime. It does provide functional style of programming, but certainly it's not a purely functional language. In fact, anytime I've heard the word functional and JavaScript together, usually people say JavaScript is a dysfunctional language, not actually a functional language. But it does have the functional style of programming in it, so you can use higher order functions and all those good stuff. But one of the really cool things about this is you do have prototypal inheritance. Well, most of the languages we are used to, like for example, Java, C++, C#, we use class-based inheritance. Well, JavaScript, on the other hand, provides a prototypal inheritance, and that's a lot of fun. Well, that's enough talking. Let's take a look at some examples and see what we can do with it. But I want to start with some ground rules we have to be very careful about. Now, there are a few things that we would think are optional in JavaScript, but they are optional as in, I will hurt you if you miss using it kind of optional. So one of them is a semicolon. Let's take a look at an example here. Let's say we have a function called foo. Well, in programming talks, you always have to use a foo, so I took care of that right here. And let's say we have a variable or a parameter coming in. I'm going to say if n is less than, let's say 5, I simply want to return, in this case, n times 2, let's say. And then otherwise, I want to go ahead and say return. And of course, otherwise, I'm going to say else. And what do I want to do in the case of else? Simply return n itself. Let's start with this little example and see what's going to happen in this particular code. Well, this looks pretty innocent to begin with. Let's go ahead and call this function. Let's say foo and send a value of 6. Well, clearly you can see that it returned a 6 when we call this function. On the other hand, I'm going to call this function one more time, but this time I'm going to send a 3. Well, of course, 3 is less than 5, so we expect a 3 times 2, which is also a 6. But when I run this little code, you can see it gives us an undefined. In fact, why did this actually give us an undefined? Well, the reason is, notice on line number 3, we don't have a semicolon. Well, JavaScript says, you didn't put a semicolon, let me do you a favor and put a semicolon for you, right? It's very helpful language, as you can see. Well, what logic does JavaScript use? Well, one other reminder, you never use the word logic and JavaScript on the same line either. So the point really in this case is, JavaScript basically says, I'm going to take a look at this particular line of code. Oh, it doesn't have a semicolon. I want to decide whether I should put a semicolon or not. So it looks a little ahead on the next line of code and says, is this potentially, could this be a standalone expression or statement? Well, it turns out it can be standalone, and so JavaScript says, well, since that can stand alone, I'm going to put a semicolon right here. On the other hand, though, had I written this as return n times 2, notice that it does produce the right result because it doesn't make sense for a star 2 to stand alone. So JavaScript does not put a semicolon here. Instead, it puts a semicolon right here. Now, of course, this can be really annoying to say the least, so it's better to really test the code properly and make sure we put semicolons and end in the expressions or statements properly. Otherwise, we could get into real trouble with this language. Well, then comes along one other really charming feature in the language. So for example, if you're writing JavaScript, let's say you want to define a variable called local1 equals 7, and I want to print the variable, let's say local1 right here. And I'm going to call this function, let's say foo, doesn't matter what value I pass to it. And of course, when I run this code, you can see it printed 7. But I'm going to ask it to print local1 right here. You can see it gives me an error because I obviously cannot really access that variable, local variable, within the function. I cannot access it right here. So that seems to be really, really good so far. On the other hand, I'm going to go back to this code and say, I'm going to define local2 equals, let's say, 8. I'm going to print local2 right here, and you can see that it's printing the value of local2. However, notice that in this case, I did not put var in front of local2. So JavaScript looked at this code and says, hey, look, Venkat forgot to put var in front of the variable. What's the worst thing I can do to make him unhappy? And of course, you know the worst thing you can ever imagine is making globals variable, because that really hurts. And so it decides to make this variable a global variable, as you can see. Now, of course, where this becomes a lot of fun is when you write code like the following. For example, had you written I equal to 0, I less than n, I plus plus, and of course, in this case, let's say you call another function, let's say f1, and within the function, let's say f1, let's say you also have yet another for loop. This is called real fun right now, because when you take this variable I, that's a global variable I. Basically, the short answer is you're screwed, right? Try debugging this code. It's going to be an entire afternoon. This is a lot of fun. So the only time you don't put var in your code is if you hate everybody that you work with. Otherwise, always put the variable var, because it makes variables global and becomes really annoying to work with. So how do you really deal with it? Well, one way to deal with this, of course, is, let's go back to this code. I say in this case, local2 equals, let's say 8. You can see in this case, it made this variable global. Well, one way to avoid that is to say, option, use option, basically option strict, and you can say in this case, you want to really use the option strict, and you can see that it gives you an error saying you cannot use the variable because you haven't defined it. And of course, once you define it, you get the error because you cannot access the variable outside. So the point really is you can definitely avoid the problem by using the option strict. And I strongly recommend that you write code, JavaScript code, using the option strict. That's a really good idea. So you can avoid these kinds of problems quite a bit in coding and doesn't slip through so easily. So we saw a few problems here, but let's continue a little bit further. Let's say I want to write a function. How do you really write a function? Well, I'm going to say there are 2.5 ways of writing a function. Well, let's talk about the first way to write a function. You've probably seen this way quite often, and that is you can say, in this case, function foo, and then of course, in this case, I'm going to simply say foo, let's say, called. So this is one way to write a function, and of course, you can call the function right here, and that's a common way we have all seen functions being defined. I'm not a huge fan of this approach, and I'll tell you why I don't really like this a whole lot. Well, what if I were to say function foo one more time? And in this case, of course, I'm going to say in here, let's say foo, let's say redefined over here. And of course, I'm going to call foo one more time. Now, when I run this code, of course, the question on hand is, what's the output going to be? Well, I'll tell you what the output should be, in my own opinion. I want this to produce foo called, and I want this to produce foo redefined. But of course, JavaScript and I rarely agree with each other. So you can see in this case, it produced a very different result. Now, this is a complete mess, but in our field, we do something really well. We mess up so bad, but we give beautiful names for those mess. It is called hoisting, and so it doesn't feel that bad anymore. So hoisting basically is, it really is defining a variable at this point for the function, but it's a two-pass evaluation, and so it really replaces the function with the newer definition, and it starts messing things up. So we'll get into some of these problems quite often if we write code like this. Well, rather than defining a function this way, we could actually define a function using the var keyword, and I can say foo equals function, for example, here, and this is the option that I actually prefer for a couple of different reasons. The first reason I prefer this is, first of all, it doesn't have the hoisting problem like we did a few minutes ago. And secondly, this keeps it very consistent in the way you define functions, whether it's anonymous function or a regular function. You always create an anonymous function and assign it to a variable, so that becomes a very consistent practice to write the code. So in this case, what I'm going to do is simply say foo called. Let's go ahead and say that. And I'm going to call the function foo, but here I'm going to say function one more time. But in this case, I'm going to say foo redefined right here. And then, of course, I'm going to go ahead and call the foo function one more time. But notice, unlike the previous example, this produces the right result because you define the variable, assign it to a function, and then you invoke that variable as a function, and then you reassign that variable like you normally reassign variables. So that's a very natural way of doing things. There's nothing really surprising behind the code. And in programming, you really want to avoid surprises as much as you can, because the more surprises, the more errors we have in code as well. So that makes it a lot easier to work with. So that gives you an idea about the second way of writing code, or writing functions. And this is the way I really like to write functions as well most of the time. But then I said there are 2.5 ways of writing functions. What is the other half way? Well, sometimes people do the following. They say foo equals, var foo equals function foo, and then of course you can call the function one more time. Well, why would anybody write the code like that? Well, people writing this code usually work for this department called Department of Redundancy. So you don't really have to do this. So the point really is, they would argue this gives you a nice way to deal with recursive functions, but most of those are really myths and special cases. We really don't have to do this. So I would encourage actually avoiding this case as well. It's not really that much fun to work with. So we saw some of the ways we can define the functions. But let's move on to talk about the parameters the functions actually take. So for this, let's take a look at an example of how we would be working with a function. Let's define a function called max, for example. And then I'm going to say this function has a and b as two parameters. And in this case, I'm going to say if a is greater than b, I want to simply return a. Otherwise, I want to simply return, let's say, the value of b. So let's go ahead and try this. Max of, let's say, 1 and 2, well, clearly it gave us a 2. On the other hand, if I say max of, let's say, 3 and 1, it also gives us the value 3, which is correct. So everything seems to be going right, just fine. But what if I call max this time, but I send a 1, let's say 3 and 2? Well, now I'm passing 3 parameters wherein I have defined only 2 parameter variables at this point. Well, if you were writing code in C++, Java, or C#, at this time you will get a very stern compilation error saying you are passing way too many parameters than what is expected. But JavaScript will never ever scream at you. JavaScript actually treats you like a guest in its house. So it doesn't really complain. In fact, when you look at this, you say, whoa, that's awesome. Look, it produced the right result. Well, actually not. So if you change this to a 7 on the other hand, you know it was just lying. So in fact, it exactly treats you like a guest in its house, because if you put the coffee mug in the wrong place, your host doesn't tell you you're stupid. They just smile to indicate that you're stupid. That's kind of what JavaScript really does, right? So it doesn't really complain on your face, but it misbehaves quietly behind the scenes. But what's really happening in this case? Well, what's happening in the case of JavaScript is, unlike languages like Java and C#, where the number of parameters that a function can take is decided by the function declaration, that's not the case in the case of JavaScript. JavaScript, the number of arguments you can pass to a function is decided by the caller of the function, not the way you are defined it. So how many parameters can I send to a function? As many as you want to send to a function. That's as simple as that. Well, in a way, if you really think about it, I could say, for example, maybe I know the name of the first 2 gentlemen here in the front row, but it would be really, not right to say there's only 2 people in this room because I know these 2 people's name. Obviously, there are several more people, I just haven't gotten to know their name yet. In a very similar way, the parameter list can have as many parameters as you like to have, except that you are given the names for the first 2 parameters as A and B in this case. So just quickly to take a look at an example of this, if I were to go back to this code and print out arguments, well, the word arguments is a keyword in JavaScript that refers to the arguments that a function is going to receive at the time of the call. So in this case, if I were to call, let's say, Max over here and pass 2, 3, let's say 7 and 5, you can see in this particular case that the function is reporting those as parameters being passed in. On the other hand, if I change this to sending one more thing, you can see that's expanding as well. So in other words, while you do have a name A and B, it really doesn't matter. These are just symbolic names for the first few parameters, but the parameter list really is actually the arguments that you can actually pass. So what you can do in this code is you can start writing something along these lines. You could say large is equal to arguments, for example, and then you can take the first value 0, and then you could say, for instance, in this case, I equal to 0, I less than arguments dot length, I plus plus, and then of course in this case you can say if large is less than arguments of I can then say large is equal to arguments of I, and you can see in this case we can write the code in a very generic manner. And so if I were to, of course I want to return the large finally, so let's go ahead and return the large variable. So in this case, you can see, if I call Max with 1 and 2 like we did before, that seems to be working just fine. Let's go ahead and call this with, let's say, 3 and 1 like we did before. That's working as well. But let's go ahead and call this with a 1 and, let's say, a 3 and a 7. And you can see that's working as well. So you can start using the arguments. Of course, you may have to do a bit more error checking to make sure the arguments is not empty after all. But you can put more logic after testing that piece of code. But this shows us how the arguments actually works. So the true nature of JavaScript is you can pass as many arguments to a function as you want to, and that gives you ultimate freedom and flexibility in how you want to call the functions. But this also leads us to one other thing, which is a context variable that every function actually carries. So in other words, when you have a function, every function has an implicit this variable that it actually carries. So within a function, you can call upon the this, and sometimes it's assigned to something you would expect. Sometimes it's assigned to something you didn't expect. That's when the fun really starts. But every function has a this reference, and so it's a context object that you can actually use. Now, of course, it doesn't make a whole lot of sense to talk about this without really setting a context. So I will talk about this in combination with the next one I'm going to say, how do you really call this function if you are really interested in calling the function? Let's define a function called greet equals, and I'm going to say in this case I passed a name, and within this I'm going to say, well, hello, and then say plus name, and I'm going to call the greet function, let's say greet, and let's go ahead and say Joe right here, and you can see that it says hello Joe. Well, this is a very common way we are used to calling functions. However, there is one idea in JavaScript which is pretty different from how we are used to in Java, C#, and language like C++, and even Ruby or most object-oriented languages for that matter. Well, in most of the languages, a function belongs to a class. So you would say this is an instance function of this class. Well, that's not the case in JavaScript. In JavaScript, you could be walking along the beach and you find this beautiful little function and you say, hey, you look really nice, I want to own you. And you can take ownership of a random function and make it part of your object if you wanted to. Well, how do you do that? Let me show you an example of how you can actually do that. So notice what I'm going to do here in this code. I'm going to change this to quietly, I'm going to say this dot to uppercase. Now that's a pretty random little this dot to uppercase, but let's see what that actually means in this context. Well, when you call the greet function, I am using the context object called this, and then I'm calling a to uppercase on the context object. So this function doesn't belong to any class or any object at the moment, but quietly it wishes that it belongs to. And so what you can do in this case is, you would go to this function and say greet, and you don't want to call Joe like this because it's going to miserably fail because there is no function called to uppercase on whatever that victim object that was associated with. But instead what you can do is you can do a call over here, and the first parameter I'm going to say is hello, and you can see how beautifully that became hello in all uppercase. So what is the difference between directly calling this function versus using a call function? Well, the call function, well, first of all, functions are just objects in JavaScript. And so you went to this function object and said, hey, function object, I'm not just going to call you. I'm going to first call you by attaching a context object to you. This is an extremely powerful feature because you can take any function and you can give an association of that function to another context. We're going to see how this comes into play in just a few minutes. So in this case, we took hello as the context object. Now, clearly, if I call greet at this point and call hello, and I'm going to say howdy, comma, let's say Jane over here, and you can see in this case, it became howdy, Jane. So we call exactly the same function twice, but we have established a different context object each of the time. So the call function takes n plus 1 parameters. So if you have n parameters, you would pass n plus 1, where the first parameter becomes your context object that you're going to pass to this particular function. Now, clearly, while this is working just fine for us, let's say we have names equal to, and let's say in this case we have a collection of names, let's say our good friends Tom and Jerry right here, and I want to call this function. How would I call this? Well, we could say dot call, and sadly, I would have to say in this case hi, comma, and then names square bracket 0, and then names square bracket 1, which is kind of silly if you really think about it. And of course, I have two names that I'm going to pass in. Let's go ahead and change the function to say I want to pass two names in this case. So I have a name 1 right here and name 2, and of course, I could say name 1 plus, and let's say name 2. Well, if you notice in this particular example, we called the Tom and Jerry as two parameters, but I really don't want to take a wonderful array and start splitting them into these individual values, which kind of doesn't really favor a good fluent code. Well, thankfully, we don't have to do this. That's exactly what apply is for. So apply and call has only one difference. They both take the first parameter as the context parameter. So notice in this case, I said hi, but apply takes an array of values, whereas call takes discrete values. So if you already have a collection of objects, you can readily use the apply and pass the collection rather than having to split them into pieces. So depending on what you're trying to do, you can either use the call function or the apply function, and you can use either one of them. If you want to just pass an array, use the apply. If you want to just pass discrete values, then use the call function. It becomes very easy easy to work with it, as you can see. So we saw quite a few things already. We saw how to set a context object using call, how to set a context object using apply. We saw that the context object itself is the this within the function. We're going to put all of these together in what we're going to see moving forward. But let's take a quick break and talk about a few interesting things before we get back to that. Well, you can use higher order functions very effectively. So for example, if you're using a collection of values, let's say list is equal to, let's say 1, 2, and 3, and I want to iterate and print the values in this list. Well, if I want to iterate and print the values in this particular list, you could have said var I equal to 0, I less than list.length. Well, this is really boring. We don't have to do this, thankfully. We can say list.for each, and we can then specify a function. We can say here is an element, and I can simply ask it to print the element out from this particular collection. We could use a code like this, a functional style. I wish more people would write code like this in JavaScript, because JavaScript has all the functional style functions. In fact, I would argue JavaScript actually has some better functions than both C# and Java actually have in terms of some of the beautiful things you can do with this. Well, I don't want to just print the values. I want to print the double of the values. Well, clearly we can do that easily here. All I have to do is simply say map, and given a function with the element e, return e times 2, and you can see that in this case I'm actually printing the double of the values rather than just printing the values. Notice how concise the code is with the functional style that we can begin to write the code very easily. But I don't want to print the double of all the values. I want to print the double of only even values in the collection. Well, very simple. We can tag along one more function, a filter function, where given an element, I'm going to say return element mark 2 is equal to 0, and you can see that in this case we are printing only the double of the even values in the collection. So you can see that you can write pretty much a functional style of code in JavaScript. Nothing stops you from really making use of it. In fact, moving into JavaScript or ECMAScript 2015, this is going to become only better, because the way this code is going to change in ECMAScript 15 is you're going to change this to a E, and you're going to simply say in this case E mark 2 is equal to 0, and the syntax becomes a lot lighter, as you can see. That is ECMAScript 2016 syntax, so the code doesn't smell as much moving forward, and you can also benefit from this also here. As you can see, this is again a ECMAScript syntax where you can say return the double of the value, so you can see the code is becoming a lot lighter in terms of the syntax itself. And likewise here also I can remove that function, and I can simply put a little lambda, or they call it as an arrow function, and you can use that very readily. As you can see, the code becomes a lot more concise moving into ECMAScript 2016. So this is really a good direction to move forward, and the code becomes very concise, as you can see, that you can benefit from. So we saw the functional style of code, but I want to talk about one caveat. We got to be very careful when we work with JavaScript. So if you ever talk about math or concepts in arithmetic, you got to be very careful when you deal with JavaScript. So for example, let's say a is equal to 1, and I'm going to print the value of a. You can see it's a 1. I'm going to now say, in this case, ask for a variable b equals to 1. So in this case, of course, the value of b is a 1 as well. I'm going to now define c equals 1.0, and of course, I'm going to print the value of c as well, and you can see that's the value that I printed. But now I'm going to say, hey, JavaScript, tell me something. Is a equal to b? And JavaScript faithfully says, of course it is. Great, thank you. Now I'm going to say, is b is equal to c? And JavaScript says, of course it's true. Now this is where you get really wrong, because you're mixing JavaScript and logic. And now you're saying, if a is equal to b and b is equal to c, then of course a should be equal to c. And JavaScript says, no, right? So you never show this to children, because they will lose faith in every civilization in the world that we have really created so far, right? So you can see this is completely illogical, but why? And the reason for that is the double equals is absolutely messed up. And if you look at code on the web, including my own code, most of it is absolutely wrong. And the reason is a double equals does not do comparison, it does comparison by converting types of objects, which is not what you really want most of the time. So how do you really fix it? The first rule is do not use double equals anymore. So instead what you do is you can use 3 equals. If anybody asks you why, tell them you're really cool because you like to use 3 equals rather than 2 equals. Well, you can see in this case it consistently says false for all of those things because obviously the type is different, and the only time a triple equals is going to give you the right result is when the type is first of all the same and then the value is equal. If the type is not the same, it's going to give you a false to begin with, so you don't have the mess that we ran into. Likewise, if you want to use a not equals, so for example, if you were to say A is not equal to B, notice it tells you false in this case, but it should be really true because A is really not equal to B. So in this case, you want to use the exclamation and 2 equals, and that is basically the syntax for comparing not equals as well. So that's the right syntax you really want to use. 3 equals versus an exclamation and 2 double equals. That's basically the syntax you want to use to do the comparisons and not comparison as well. Well, we talked about a few pitfalls you got to be careful with, but let's talk about functions as objects first of all. And functions are really objects, and objects could be functions as well. So it treats that very interchangeably. And of course, these can have properties as well. We already saw this a few minutes ago. You were able to call the call method on the function. You were able to call the apply method on the function. So that gives us a clue that functions are kind of like objects. They carry a few methods or functions with it. But I want to focus on creating an object right now. Well, one of the really nice things I like about JavaScript is you don't need to create classes if you really want to create objects. You can readily create objects very easily. So let's take a look at an example here. I'm going to say Sam equals, and I've created an object here. I'm going to say first name for Sam. Let's say that's our first name. Last name, let's say in this case, last name I'm going to give for the Sam. And I'm going to say age is going to be a little age value. Now you can see in this case, I can print the variable Sam. Well, that's an object, obviously. I can call upon the age of Sam and print the age of Sam. But I can also say Sam.play, and I can invoke a function on Sam as well. So in this case, I'm going to go ahead and create a play function, which is simply a function itself. And I'm going to simply say, let's say playing right here. And you can see that I'm able to call that function on this particular object. Well, we know these as JSON objects, so you can create JSON objects and easily pass them around. So it's a very lightweight syntax. It doesn't burden you to create classes before you can have objects. So a lot of times I don't even bother creating classes. I just create objects and float them around, and that becomes a lot easier to work with, so you can readily create objects. But one really nice feature that you can have on these objects is the concept of prototype. So what is a prototype? Well, a prototype basically is an object. Think of this like a bag if you want to think about it. So for example, let's say you come to me and say, hey, can I have a change for euros, please? Well, sure, I can give you a change for euros because I've got some euros in my wallet. I can give you change for euros. But if you ask me, can I have change for some dollars, please? I don't really have a reason to carry dollars this week. I could say no to you, but instead of saying no to you, I'm going to go and reach into this wonderful bag, which carries every other junk that I own. And if I reach into it, I can get you the change for dollars. So the point really is, I have to really reach into my wallet, but oftentimes I can reach into my bag as well. And you can think of this as a prototype. So a prototype, think of it as a backpack that every object carries around, except that that prototype in JavaScript is really cool because that backpack has another backpack potentially, and that keeps going until there's no backpack. So the point really is you can have a chain of these prototypes really nicely. So notice what I'm going to do here. I'm going to go to this particular object, and Sam is really too young, but let's get rid of the age for a minute. And let's say in this case worker, and I'm going to say worker is equal to, and I'm going to write a function here. Let's go ahead and define the function as a work function. And in this case, it's a function, and it's simply going to say, let's say, working. Now you can see I have a little Sam object on my hand, and I'm going to go ahead and call a function, let's say use Sam. That's a really poor name for a function. But anyway, I'm going to pass the object instance. We'll call it a use function. And I'm going to pass the instance, and I'm going to say try and let's say catch exception. And I'm going to print the details of the exception. Well, in this case, I'm going to say instant.work. Well, you clearly can see our little Sam doesn't have a work method right now. So I'm going to call use and send Sam to it, and you can see that it immediately says inst.work is not a function. So I got an error saying I don't have a function after all called work. Well, it's clear that Sam doesn't have a work function. But notice what I'm going to do now. I'm going to say sam.proto, and then I'm going to say equals, and in this case, I'm going to set the worker as the prototype, if you will. So what I just did is I took our Sam object and assigned the prototype of the Sam to the worker object that we had right now. So this is like attaching a backpack to little Sam and say, here you go. Now I call the use function and pass the object Sam, but notice this time it doesn't give us an error. Instead it says working. Now this is an extremely powerful concept, as you can see. Why? Because I can also do the following. A mock worker and then equal to, I can say work, and this could be a nice mock function I could create, for instance, and then I could say, pretend to work. This is a nice feature to have some days. And then of course I can say sam.proto is equal to mock worker and use Sam in this case, and you can see it says pretend to work. So it's extremely simple to modify the prototype. So testing becomes incredibly simple the minute we start engaging prototypes, and I employ this a lot of times when I do automated testing, automated unit testing for JavaScript. I often create a proxy object, refer to my main object, and then during testing, I hijack functions on the main object by introducing a middle prototype. So this becomes very convenient for doing automated testing of code. That's a really powerful way to deal with things very quickly. So this gives us an idea about how we can actually use the prototype on objects and benefit from that very powerfully. But let's take this concept one more further down. How about creating classes? Well, let's create a class called car. So I'm going to say car function, and there you go, we created a class. You say, wait a minute, you created a function. No, trust me, we created a class. If you don't believe me, did you notice the uppercase C? Well, that's a convention that JavaScript follows, which is kind of silly. But this is what is so beautiful, right? When you're a programmer, you never look at code, you see code. And these case differences are really, really important for us programmers. The non-programmers would look at us and say, you guys are weird, but that's the world we live in, and this means a lot to us. Well, in JavaScript, the case that you assign for a function decides whether it is a regular function or it's a class. But actually, let's be honest about this, JavaScript doesn't have classes. So what in the world is this? Well, if I say a lowercase c, I simply wrote a regular function. If I put an uppercase c, I simply wrote a factory function. In other words, this is nothing but a constructor that you are writing. So in JavaScript, you never write classes, you always write a constructor. And a constructor can produce the object for you. Now in this case, of course, I'm going to say year, and this dot year equals the year value. Now you know where that this comes into play. It's the context object on which I want to set this. But how do I go about using this? I'm going to say in this case, let's call it as car created. Let's go ahead and use this function. I can say car like this, but don't do this. Now notice JavaScript doesn't complain. But what you just did here is you just call the constructor function directly, and JavaScript kind of looks at you and says, that's silly, and it still lets you do stuff, right? It never ever complains, as you know. So this is really meaningless to call it this way, but you could if you really wanted to. It doesn't care. But the way really you want to call this is you want to say car1 equals new car 2015, and that's exactly what you want to do. Now if you say car1.year, here, you can see that object was created, but you also have the year value in place. But let's understand the meaning of this piece of code. What does this new stuff really mean? And it's actually very simple to think about. It is a three-step process, what just happened here, and we already covered all the three steps, so it should be very easy for us to understand what's going on in this code. The very first step is memory is allocated for the instance. Let's call that inst. So you have a little instance, a memory has been allocated for that instance. What does it do next? The second thing it does is, it calls, in this case, so calls, what does it call? Well, instant.call, well, pardon me, a car.call instance, comma, 2015. So it makes a call to the call method and passes that memory instance as a context object and says, go ahead and run this in the context of that. So now you know why on line number 2, this dot year is setting the object's parameter, because that becomes the context object. The third step here is instance.proto is equal to car.prototype. So you can see what's the last step in this case. It takes the object you created and assigns the prototype of the object to be the prototype of the function itself. On the object, it's called underscore underscore proto. On the class, well, the constructor, it's called fully spelled word prototype. So this shows a few things for us. When you create multiple objects, the multiple objects actually share the same prototype. And this is a very powerful concept because JavaScript can create hundreds and thousands of objects, but the objects actually share the prototype, and that can be very efficient in memory as well. And so this is called the prototypal inheritance. So in Java and C#, we are used to class-based inheritance, where a class inherits from another class. In the case of JavaScript, you have prototypal inheritance, where an object inherits its stuff from a prototypal instance. This is a very powerful inheritance model. Class-based inheritance is rather static and very limiting. Prototypal inheritance is extremely powerful and flexible. It's really a shame that we don't use this really that often in a lot of languages, but this is one of the most charming features of JavaScript, is the prototypal inheritance that you have available in the object. Now let's talk about what this means when it comes to creating these objects. So notice, in this case, I'm going to create an object car1, and you can see that I have a year for the car1. But let's do something a little different. I'm going to say car.prototype dot, and I'm going to say miles equal to 0. So notice how I created a little miles within the prototype. And so this miles is part of the prototype. And I'm going to say car.prototype.drive equals to function. And in this case, I'm going to say that my drive function is going to take a distance over here. And then, of course, I'm going to say this dot miles plus equal to distance. I apologize, I have to use miles because my brain is wired to miles and not kilometers. So, sorry, your car is going to be better than mine, obviously. It'll have kilometers than miles, but mine sucks. Okay, so right there is the miles value I'm going to say. Well, how does this really work? Let's talk about this for a minute and see how this is going to behave right now. So you can see I have a miles, I have a drive, all those good stuff. But before we go any further, let's say var car2 equals new car 2017. Well, let's say 2016. It's a brand new car. It's November. We can have new cars. Great. Now I'm going to say output, in this case, car2.year. And clearly you can see the year values are different. I'm going to remove this message so we see less output on the screen, so you can see those 2 years being printed. But let's look at something else real quick. I'm going to say car1.proto is equal to let's say 2.proto. Well, question for you. What do you think is the answer, true or false? I'll give you a clue. It's either true or false. What do you think? True, absolutely, because remember the 3 steps we talked about. When you create car1, Each prototype points to car's prototype. When you create car 2, what does it do? Each prototype points to car's prototype. So both of them have exactly the same prototype. Well, wait a minute. Let's now ask the question, car 1.miles is 0. Let's ask the question, car 2.miles, 0. That makes sense so far. Now I say car 1.drive 10, and I'm going to ask for car 1.miles. Hey, that's 10. Now I'm going to say car 2.miles. Oh my goodness. What do you think? Would you be happy if car 2 moved when car 1 moved? That's called voodoo, right? That's not programming. So our logic seems to be in trouble, right? Because we just said the objects are shared, but what do we do now? Let's understand this with a little example. Could you kindly volunteer for me? Would you be? You can sit there, and you can happily sit there. What's your name, sir?
Alex.
Alex, you are my volunteer.
All right.
Everybody knows this, right? You are accepting? Great. So Alex is my volunteer, and Alex, you're my prototype.
All right.
All right, so here's my prototype. He's pointing to it. What is your name, sir? What's your name?
Emrich.
Emrich?
Emrich.
Well, our good friend comes to me, and he says, Venkat, I'm in a rush. Could I please borrow $1 from you? He seems like a nice guy. Anybody can vouch for it? Okay, all right. So he's got a little bit of trust being built up. So here's my dollar for you. Take it. And about 2 hours goes by. He comes back and returns my dollar. Thank you, sir. You're a nice person. I put it in my wallet. So everything went fine, but something else happened. We now built a trust. You are trustworthy, right? So 2 days goes by. He comes to me and says, you've been such a great help 2 days ago, but I'm in real trouble. Could I please borrow $100 from you right now? Trustworthy? Seems like. But there's a problem. I don't have $100 on me. What do you think I should do? Ask my prototype. Alex. There we go. I got it from Alex. I give it to him. Here you go. 2 days goes by. Guy is still trustworthy. He gives me the $100. Can somebody suggest what should I do with this $100? Keep it. That's right. Does anybody have a problem with it? I'm not looking at Alex, obviously, right? Well, if you understood what I just did, you understood how JavaScript works. So in JavaScript, this is a fundamental concept. Gets are deeper, sets are shallow. So notice what I did. When he came to me and said, can I get $100 from you, please? You know what? I don't have $100. Gets are deeper. I go to my prototype and say, Alex, can I have the money, please? Well, Alex may not have the money. What is he going to do? Go to his prototype, right? And behind him is the big Swiss bank. So we all can get the money, right? But the sets are shallow, which means when you come to set it, I am not going to go any deeper. I'm just going to keep it. So now when you go back and ask the question, hey, what is car 2.miles? Notice the answer is still 0. Why? Because car drive said this .miles, but what in the world is this? This is a context object. In this case, the context object is the car object, not the prototype. So as a result, it was set on the instance, not on the prototype. So that is the magic behind how JavaScript very efficiently shares the objects, but it doesn't mess up the shared state because it goes deeper to get the objects when it doesn't exist. But when you do a set, it sets on the object, never goes down to the prototypes. Please.
Doesn't ES6 though solve this in a sense that you don't have a this on your function?
Well, actually you do. You actually have a this. But the difference in ECMAScript 2015 is functions and arrow functions both have a this, except that in the case of arrow function, your this is actually tied to the context of where you come from, whereas this are very different. So it doesn't really solve this problem still. This is not even a problem. This is a feature. Don't blame it as a problem. Okay. So the point is, it still behaves properly. So the fact that this is out of bounds or context is a separate problem than this one. Well, Now, this takes us to the next level. Notice how this actually nicely deals with it. So the gets are deeper and sets are shallow, and that's basically how the sharing happens. Well, it would be nice to really take a look at this. So how do we really understand this is actually working the way it's supposed to? So to understand this, let's do the following. I'm going to go to this object and say, hey object, I want to examine your properties after all. So I'm going to say var over here, var, and I'm going to ask for the property on this object, prop, let's say prop, in car1, and I'm going to simply print out the property that I have on my hand. You can say it's a liar. It tells that it's got properties. So you can come to me and say, Venkat, are you rich? And I will say, of course I am, because I've got Alex, who in turn has a big bank behind him, right? But then you say, Venkat, are you really rich? Well, that's a different story, right? So the point really is that I can actually look for all the properties, but I can now say, well, but tell me, is that really your property? And so that's a very different question, as you can see. So if I go to property plus, and I'm going to now ask it car1 dot has own property prop, you can see it's a false for miles and drive, because those two properties actually come from the prototype and not from the real object itself. On the other hand, if I were to say car1.drive 10, and now you can see that I've actually called the drive function on it. Now if I go back and ask the question, are these your properties? Notice how miles went from false to true, and that's because, remember, sets are shallow. So before the call of the drive function, the property miles was in the prototype, but when you call the drive function, the property becomes property of the object, and it's still in the prototype, but it's also on the object. So when you ask him, is it your own property, you can say it says true rather than saying false, and that's when the set happened. In the same time though, had you created your car2, so car2 equals new car, as we did before, 2016 as you can see here, but now in this case, if I were to ask the same question of car2, you will notice that in here, this is for car2, as you can see, it says miles is actually true. Well, did I say the car2? So this is going to be car2, and this is going to be car2, obviously. So you can see in this case, it's a false, because car2 doesn't have the property. It still reaches into its prototype, but car1 has the property. So this shows you how you can actually get these properties. Now, one question you may have is, hey, this is nice that we are able to bring the property on to this particular object. So for example, in this case, if I say car1.drive 10, and you can see in this case, car1 has own property, so we can say property. So let's go ahead and ask for it. So for, let's say, var prop comes from car1, and I'm going to print in this case the property itself plus, let's go ahead and say this is going to be car1 has own property. And you can see in this case, miles is actually going to be part of this object car1. Let's make sure that I'm doing this right. And the property itself I want to pass to this. So you can see in this case, miles is part of the object. Well, that's because, of course, we call the drive function. So at this point, the car1 has the property. Now, here is one feature I'll quickly mention, but be very careful. Sometimes I use this during testing purpose, but I would say almost never in production. And that is, you can say delete car1.miles, and you can ask it to delete the property. Now, I recommend you don't use delete, because if you do, it can be very confusing. So you're basically going to this object and knocking that property off. And of course, once you don't have the property, if you ask for a get on it, it will go to get it from the prototype if it is there. And that's a bit confusing and error prone, but can be fairly useful during testing purposes. But I would very rarely go that route and use this during production. So be very careful about it. So to summarize what we talked about, we looked at a number of features here of JavaScript. JavaScript actually is a very powerful language. I really like this language quite a lot. And it's a language that is very powerful, but you have to really use it properly. And by using it properly, you can actually benefit from some really powerful features. For example, the context object is something I've used quite often. The call comes in very handy when you are trying to build a fairly complex set of objects. If you ever take a look at any of the JavaScript libraries out there, we are going to readily start looking at functions like call and apply being used quite often. So this becomes very powerful features to use. But the most charming feature, in my opinion, is the prototypal inheritance. And once we learn about prototypal inheritance, you also learn that JavaScript classes are never closed. You can always go to a JavaScript object and add methods, remove methods, change methods, or change functions. So the objects are always open for extension, and that gives you enormous power on your hand to work with JavaScript. So things like mocking and testing is incredibly easy in JavaScript. And JavaScript, of course, being a language which is so flexible, it is really unfortunate if we write code in JavaScript without testing it. So JavaScript actually makes testing extremely easy, but it also is a language that demands enormous amount of testing, and I think that's only fair, that it gives you the flexibility and demands you to really use it, so that's a really good game in my opinion. So it's a very powerful language, as I said. It's a language that really is probably the most ubiquitous language we ever use. It only is a good idea for us to take the time to learn the power of this language, and I hope you found this session useful. Thank you.